here real quick before we get moving on to page 4. This is all my typo the second I shut the video off here at the end for number 16. Take a quick look and I'll try to go and edit this on the actual video. First term is not 16, that's the problem number, it's also A. The first term is 24. So get rid of the 16, put in a 24, and all problems are solved. So 24 is the first term. 24 divided by 3/2, 24 times 2/3 is 48 over 3, which is 16, which gives us A, and therefore it is on here. Okay, just wanted to touch base on that. Now let's move on to the actual page 4 here of the midterm review, and it looks like a very similar problem to problem number 1. It is a quadratic form, but in this case it's a quartic. Either way, since this is a 4 and that's half of it, it's quadratic form. This could be an 8 and a 4, a 16 and an 8, quadratic form. So I say to myself, x squared times x squared gives me x to the 4th. And what multiplies to 4 such that it's positive and gives me 5 such that it's negative? That would be a negative 4 and a negative 1. And now I can take this and say x squared equals 4. And this one says x squared equals 1. And then x equals plus and minus 2. And here x equals plus and minus 1. So final answer, x is plus and minus 1 and plus and minus 2. 4 solutions as expected for a quartic. Consider the graph of y equals x cubed. Describe the changes that would occur in the graph of y equals x minus 5 cubed plus 3. Well, it'll shift right 5, shift right 5, and I'll shift up 3. Shift up 3. Solve. Well, these are both powers of 3. That's 3 cubed, 27 to the 3x. And 81 is 3 to the 4th. Remember, power to power we multiply, so that's 3 to the 9x. Equals 3 to the 4. We can then say that those exponents must be equal, so x is 4 over 9. Here, I'm going to rewrite this one. 7, and you know what, while I'm rewriting it? No, never mind. 7, a to the negative 5, b to the 6, divided by 21, a to the 4th, b to the negative 2. At this point, 7 over 21 is 1/3. These 5 a's are going to join the 4 down here and give us a to the 9. These 2 b's are going to join the 6 up here and give me b to the 8th. And of course, you don't need to write that 1. According to the rational root theorem, what are the possible roots of each? Well, factors of 4 divided by factors of 2. So plus and minus 1, plus and minus 2, plus and minus 4, divided by factors of 2, plus and minus 1, plus and minus 2. Okay, but those are just the factors of. The possible rational roots actually come from finding out what those ratios are. So I want to take all of these terms, plus and minus 1, plus and minus 2, plus and minus 4, divided by 1. And that gets me plus and minus 1, plus and minus 2, plus and minus 4. And now I'm going to take all of these terms divided by 2. So I get plus and minus 1/2. When I do the plus and minus 2 over plus and minus 2, I get plus and minus 1 again. Plus and minus 4 over plus and minus 2 is plus and minus 2 again. So I do not need to write the repeats. So these 8 are possible rational roots. Same deal over here. A little bit nicer because factors of 5 are few and far between, being as it is a prime number. But 6 has a couple extras, so we're going to have some more fractions going on here. So possible rational roots, after we list the factors, we get plus and minus 1, plus and minus 5. Now I'm going to put them over 2. Plus and minus 1/2, plus and minus 5/2. Now I'm going to put them over 3. Plus and minus 1/3, plus and minus 5/3. And finally put them over 6. Plus and minus 1/6, and plus and minus 5/6. And on to the last problem here on page 4. Does it have any symmetry? to y equal to the y-axis, x-axis, y equals x, and the origin. Alright, so I'm going to break these up into three things: the y-axis, the x-axis, y equals x, and the origin. And then I'm going to do a think about it. If I have symmetry to the y-axis, that means it's something like this, right? The x values are opposite while the y values remain the same. So this one I'm going to negate my x value. If I have symmetry to the x-axis, that means I have something like this, which means my y values become opposite. If I have symmetry to the line y equals x, that's these 2 points here, which means my x and y switch. And if I have symmetry to the origin, I'm looking at a point here and a point there. So my point, for instance, 3, 1 went to -3, -1, which means I negate both. So let's run the test. If I negate x, I'm still good because it's an even power and an even power, so it certainly has y-axis symmetry. If I negate y, though, I have -y equals x to the 4th minus x squared. If I solve for y, I get y equals positive x squared and negative x to the 4th. Unfortunately, that is not the same. If I switch x and y, I have x equals y. No good. And if I negate both, again, no good, because these are going to remain unchanged, and this one will change. So over here, y-axis symmetry, negate x. That's not cool, because negative x cubed is different than positive x cubed. And likewise, 2x is different than negative 2x. So y-axis is no good. X-axis, if I negate y, again, no good. If I switch x and y, I hope that's clear to see, that is no good either. If I negate both of them, however, negative y equals negative x cubed minus 2x, multiply both sides by -1, I'm right back where I started. We got a winner, the origin. That is the end of page 4. We'll see you in a little bit.